So our second lecture is on formulas, and we'd like to solve equations a little bit more general than just linear equations. So the definition of a formula is just an equation that contains more than one variable. So unlike a linear equation where we're only going to solve for maybe the x or y, just a single variable, here we're going to have several variables involved, and we'll want to solve for one in particular. So an example of this would be, okay, well, let's say that we have this formula here. So this formula has three variables, right, a y, a, and x. But we're going to specify that first x is equal to 0 and y is equal to 0, and then we'll be able to solve for the remaining variable a. So let's see what happens when we do that. So if y is 0, then we have 0 here. A is unspecified. X is 0. So we'll substitute that. So if we simplify this, we'll have 0 equals a times and negative 80 squared will give us 6,400 plus 70. And at this point, we're trying to solve for a. So we're going to try to isolate a. So to do that, let's subtract the 70 over. So we'll have minus 70 equals 6,400a. And at this point, we'll have to divide both sides by 6,400 to get a by itself. So this will reduce, and this will be our answer. So a is this right here, negative 70 over 6,400, and you could reduce this common factor of 10 here if you want to get negative 7 over 640. All right, so let's look at this example here. So here we have another formula. We have y, k, x, and z here, and we're going to try to solve for k, assuming that we substitute these three values. So if y is 180, we're going to solve for k, and we're going to substitute x equals 5, z is 3, so then we'll have 180 equals k times 5, and 3 squared is 9, so 180 equals k times 45. And then to solve for k, we'll have to divide both sides by 45. And we'll get our answer. But we can reduce this a little bit more, right? So we have this common factor. Note that 45 times 2 is 90, and 90 times 2 is 180, so then this is just 4. So that'll be our answer. Okay, now in our third example here, we have this formula, d equals rt, and we're just told to solve for t. So this solution is going to be in terms of other variables, which is fine, and many applications have you do such a thing. So if we're trying to solve for t, well, we just have to isolate the t, and since it's multiplied by r, we're just going to divide both sides by r here. So if I divide both sides by r, then we're going to get the r's reduced on this side. We would have to make the assumption that r is not equal to 0 to do that reduction, but by writing this solution right here, t equals d over r, by writing that as the solution, it is actually going to be assumed that r is not equal to 0, because that would make this undefined on the left side. So this is perfectly legitimate. That's the solution. So let's look at another example like this. So in this one, we want to solve for r if d is equal to r plus c multiplied by t. So we're going to do that first, and then we're going to redo the problem and solve for c instead. So let's first solve for r. All right, now our strategy when we were solving linear equations, we're going to do the same thing in this situation. So we're going to first use the distributive property, and we're going to multiply this t in on the right side. So we'll actually end up with d is equal to rt plus ct. And at this point, we're solving for r here. So a strategy would be to isolate the terms that have r on one side and bring all the other terms to the other side. So there's only one term with an r in it. It's this one. So let's leave that one here, and let's bring the other term, this ct, to the left side. In order to do that, we're just going to subtract ct from both sides. So then we'll have d minus ct equals rt. And we're going to solve for r. So to isolate this r, we're just going to divide both sides by t now. And the t's will reduce over here, and we'll get our solution. R is equal to d minus ct divided by t. Now to do the same thing and solve for c, we're going to start out the same way. We would still distribute this t in, so we're going to actually have the same exact equation over here. So d equals rt plus ct, but you're going to solve for c instead. So we want to keep the terms that have c on one side. So this is the only term with the c in it. So we're going to bring the other terms to the other side. So we'll bring the rt to the left. So we'll subtract both sides by rt. And so we'll have d minus rt is equal to ct. And then solving for c, we just have to divide both sides by t here. And so then we'll end up with c is equal to d minus rt over t. So our next equation, where we want to solve for t, assuming that a is equal to p plus prt. So using a similar strategy to what we've been doing, we have only one term with a t in it, so let's leave that here. And let's bring all the other terms to the other side. There's only this one term p, so let's subtract p from both sides. So we'll have a minus p is equal to p rt. And to solve for this t, let's just divide both sides by pr. So we'll have a minus p divided by pr is equal to t. Now another good problem that we could do right now is let's solve for p instead. So let's just do another problem right now. Solve for p. So also solve for p. Let's just see what happens. I think that it's a good problem in this situation. So if we want to solve for p, what do you think we're going to have to do? Well, we're going to want to bring all the terms that have p to one side, and here they are. But at this point, we're going to try to isolate p by itself. And so we have these two terms that have p in common. And in order to isolate it, we can factor it. So what we can do is we can factor this p out of both sides. out of these two terms. So if I factor a p out of this term, I'm only going to be left with a 1. And if I factor a p out of this term, I'm going to be left with that RT there. Right? And if you're ever worried whether or not you did the factorization correctly, you could just multiply back in and check yourself real quick. So if I multiply this p in, p times 1 is p times RT is PRT. So definitely correct. And now, if you want to solve for p, well, we have p isolated as this term here, and so we would just have to divide both sides by this factor. So let's divide both sides by 1 plus RT. Divide this side by 1 plus RT. And so this whole factor is going to reduce, and you're left with p is equal to this right here, a over 1 plus RT. So I think that's a good extra problem to take a look at, because it's definitely a different situation solving for p versus t. Okay, in this last example here, we're going to solve for n, and we have capital A, little n, and a d here. So if we want to solve for n, first we're going to expand so we have all these terms, because we know that we're going to have this term that has an n in it. So first let's expand. So we're going to have to distribute this d in to these two terms, right? So we'll have an nd and then a minus d. And then at this point we'll have a term that has an n in it, and we can isolate the terms that have n in it on one side. So we'll bring all the other terms to the left. So we'll bring this a and this d over here. So we'll have to subtract this a minus little a equals n d minus d, and we'll add this d over. We could, of course, done that in one step, but just kind of being consistent here with the method of choice. Okay, now we have that this term is isolated by itself on one side of the equation. N, which we're solving for, is also isolated as a factor. So all we have to do is just divide both sides by d. And then this will cancel, and we'll have n is equal to a minus little a plus d over d. And that will be our solution.